Alright, we continue with position of carbon and hydrogen in the reactivity series of metal. Okay, even though the reactivity series of metal is an arrangement of metals according to their reactivity towards oxygen, the position of non-metals like carbon and hydrogen can also be shown in the reactivity series. So as you can see in this series, we have carbon, we have hydrogen. Alright, sama juga macam tadi. Okay, the metal that are placed at the bottom, okay, no bottom, at the top, okay, is the most reactive metals, while at the bottom, usually at the bottom, is the metal that is least reactive. Okay, increasingly reactivity, maksudnya semakin ke atas ni semakin reactive. Alright. Okay, the position of carbon and hydrogen in the reactivity series of metal is determined through following experiment. Maknanya, kita boleh menentukan position of carbon dan hydrogen melalui eksperimen. We can carry out the experiment in lab. Okay, this figure is for the position of carbon, while this figure is the position of hydrogen. Okay. Alright, we go to determining the position of carbon in the reactivity series of metal. Okay, this is the diagram. This is the apparatus setup of the experiment. This is crucible. This is crucible. Okay, pipe clay triangle. This is tripod stand. Okay, so in this crucible, what do we have? We have a mixture of carbon and metal oxide. Maksudnya kita ada campuran serbuk karbon dan juga serbuk logam oksida. Okay, ataupun metal oxide. We have let's say in this experiment we use 3 type of metal oxide. Okay, let's say we use aluminium oxide, we use zinc oxide, and also lead oxide. So kita buat satu-satu. So apa yang kita buat adalah in this crucible kita campurkan serbuk karbon dengan aluminium oxide, and then kita panaskan. So what will happen is that after heating process, okay, after beberapa minit, okay, we notify that there is no reaction. Maksudnya there's no chemicals reaction at all. Tidak ada tindak balas. Okay, and then we just record lah. Okay, we just record, and then we replace the content of the crucible with new mixture. We mix zinc oxide powder with carbon, and then we heat. So after heating process, what we get is, okay, we have zinc and carbon dioxide. So actually the formation of carbon dioxide and pure metal ni, kalau kita tengok contoh yang kita tengah bincang sekarang ni adalah zinc lah. Okay, ini adalah pure metal, this is carbon dioxide. So the formation of carbon dioxide and pure metal indicates that the carbon is more reactive than the metal. So memang kita tengok dekat sini, carbon dia duduk di atas zinc. So ini menunjukkan karbon adalah lebih reaktif berbanding zinc. Dan karbon ni actually it able to remove oksigen. Okside ni kan oksigen, okay? Okside ni kan oksigen. So this carbon actually it able to remove oksigen from zinc oxide. That is why zinc dia tinggal sorang-sorang. Kita dapat pure zinc. And carbon tadi sebab dia dah remove oksigen dan dia akan membentuk carbon dioxide. Okey, carbon dia lagi reaktif sebab tu dia boleh remove oksigen from zinc. Kenapa aluminium oxide when it react with carbon there's no reaction? Because aluminium is more reactive than carbon. So carbon unable to remove oksigen from aluminium oxide. Dia tak boleh, carbon ni dia tak boleh nak ambil oksigen daripada aluminium. Okey, dia tak boleh. Sebab apa? Aluminium oxide ni lagi power, lagi kuat. Lagi power, lagi kuat tu adalah analogi sahaja ya untuk awak lebih faham. Okey, kalau dalam terms, the correct term is that is because aluminium is more reactive than carbon. That is why carbon unable to remove oxygen from aluminium. Okay, now we proceed to lead oxide. Sama juga macam zinc oxide tadi. Lead oxide, okay, when it react with carbon in this crucible, okay, and we heat the mixture, what we get is we get pure lead and carbon dioxide. Okay, the formation of carbon dioxide and pure metal ni menunjukkan carbon ni adalah lagi reaktif. Carbon is more reactive than lead. Lead duduk dekat sini. This is lead. Okay, dia duduk di bawah berbanding carbon. Carbon kedudukan dia adalah lebih tinggi. So ini menunjukkan carbon is more reactive. So carbon able to remove oxygen from lead and form carbon dioxide and pure lead. Okay, inference from the experiment. Okay, carbon is less reactive than aluminium. Betul lah Kita tengok dekat sini carbon dia duduk di bawah aluminium. So it means that carbon is less reactive than aluminium. Aluminium is more reactive lah. Okay, but more reactive than zinc and lead. Maksudnya carbon is more carbon is more reactive than zinc. Mana zinc? Zinc and lead. So this is inference. And from this experiment we can arrange all the metals according to their reactivity. Okay, kalau yang ini susunan secara menurun lah. Okay, ini susunan secara menurun. Maksudnya yang paling reaktif dulu, barulah yang kurang reaktif. Yang ni kita ada mulanya kita ada aluminium followed by carbon, zinc and lead. Alright. Okay, next. Determining the position of hydrogen in the reactivity series. Dia punya konsep quite similar with position of carbon. Alright. So this is the apparatus set up to determine the position of hydrogen in the reactivity series of metal. So what do we have is, okay, in this glass tube, okay, we have porcelain plate, okay, whereby we place the metal oxide on the porcelain plate. Okay, and we heat. So dari mana datangnya gas hidrogen? Okay, gas hidrogen tu datangnya daripada tindak balas di dalam round bottom flask ini. Okay, we have dilute sulfuric acid plus copper to sulfate and zinc metal. So the reaction will release hydrogen gas. We release hydrogen gas, and the hydrogen gas will flow through the delivery tube and then go to anhydrous calcium chloride and then dia akan jadi dry hydrogen gas. Maksudnya masa dekat sini yang ini adalah wet hydrogen gas. Hydrogen gas yang dalam keadaan lembap. Okey, and then kita lalukan dia dekat anhydrous calcium chloride yang mana function of this anhydrous calcium chloride adalah to absorb moisture. Okay, and then the product is we have dry hydrogen gas. So the dry hydrogen gas, okay, kita gunakan, okay, in the reaction with metal oxide. Alright, maksudnya metal oxide ni dia akan bertindak balas dengan dry hydrogen gas. Okay, sama juga macam tadi. Okay, let's say we have several examples of metal oxide. We have aluminium oxide, we have zinc oxide, lead oxide and iron oxide. So in this porcelain plate, we place first the aluminium oxide and we let it react with the hydrogen, and after a while there's no chemicals reaction. Samalah juga dengan zinc oxide ni. Okay, when we replace zinc oxide, we place zinc oxide on the porcelain plate and let it react with the hydrogen. Okay, there's no chemicals reaction. Why? This is because aluminium and zinc is more reactive than hydrogen. Okay, therefore hydrogen cannot remove, unable to take the oxygen from aluminium. Okay, hydrogen unable to remove, unable to take the oxygen from zinc. That is why there is no reaction. Okay, however, when we place lead oxide in the porcelain plate and let it react with hydrogen gas, what do we get is we have lead and water, pure lead and water. That is mean, okay, hydrogen is more reactive than lead. Lead duduk dekat sini. Nampak tak, perasan tak, hydrogen ni duduk di atas lead. So ini menunjukkan hydrogen able to remove oxygen from lead. Dia boleh rampas oksigen daripada lead. Sebab itulah hydrogen akan membentuk water. As we know, okay, the chemical formula for water is H2O. So hydrogen masa permulaannya di sini, hydrogen, okay, dia ambil oksigen daripada lead ni dan dia bertindak balas dan dia membentuk air, dan tinggallah lead sorang-sorang di sini. Okay, so ini menunjukkan hydrogen is more reactive than lead. Lead is less reactive than hydrogen. Sama juga dengan iron oxide. When iron oxide react with hydrogen, kita akan dapat iron plus water. Kenapa? That is because iron is Fe, ni Fe kat sini. Iron is less reactive than hydrogen. Hydrogen is more reactive than iron. So hydrogen able to take oxygen from iron and form water and iron. So the inference is hydrogen is less reactive than aluminium and zinc, but more reactive than iron and lead. Reactivity arrangement maksudnya we can arrange. So we start with aluminium, zinc, hydrogen, iron and lead. Alright, so that's all for reactivity series of metal. InsyaAllah we will proceed, we will continue with other topic after cuti hari raya. Thank you.